All right, in this video I want to teach you a little a method for quickly ascertaining how to do a mole conversion. So this is very similar to the mole flowchart that I gave you when you're going from grams of an unknown to grams, or grams of a known to grams of an unknown. So we take a look at this. This will help you convert from 3 different units. So if you're given grams, you can get to moles, or if you're given volume, you can get to moles, and if you're given particles, you can get to moles. So let's take this out for a test drive, and let's see how this works. I'm sorry, or hopefully you like the black background. This is a new look for me. So let's just say that we had 5.1 grams of NaCl, and we want to convert that to moles of NaCl. Okay. If we take a look at our chart, we have grams and we want to get to moles. And so when you're going from grams to moles, using this chart, you can see that you're going to divide. We're going this way, so we're using this arrow, divide by the molar mass. Now, I want you to be able to set up the factor label, or the dimensional analysis, for this. Remember that we can call that either name, factor label or dimensional analysis. So 5.1 grams, we're going to put the molar mass of sodium chlorate, which is 58.5 grams, and that is 1 mole. And grams of NaCl cancel, and we get 0.087 moles of NaCl. Okay, so that's one way you can use the table. But I want to take a look at a couple different things on this chart. So let's take a look at a problem, something like this. Let's say that we have 8.4 liters of carbon dioxide gas. And one thing, and when we get to the gas laws, something called gas laws later, we'll talk a little bit more about this, but it turns out that if I have 2 balloons, so let's say I have a balloon full of carbon dioxide and then I have a balloon of oxygen, that at something called STP, that if each balloon had a volume of 22.4 liters, they would each have 1 mole of gas particles inside. In fact, it turns out that if you have equal volumes of any gas, of any 2 gases at STP, that they contain the same number of particles. And we'll see why that is later. But for now, this is for gases, and it's another mole conversion that we can make. So if we have 8.4 liters of carbon dioxide, we can go over to our mole conversion chart and we can see, well, I have volume at STP, and I want to go 2 moles. So if I want to find how many moles that is, again, going 2 moles, I'm going to divide. So, and if I set up my factor label, I know liters is going to go on the bottom, and I want to go to moles. The conversion factor is 1 mole is 22.4 liters. So now liters will cancel, and then I can get my answer, which comes out to 0.375 liters. So this chart can help you. I would still rather you set up the problems using factor label. However, if you get stuck, you can always kind of look back to this, or you kind of remember that as a way to help you get from either particles to moles, grams to moles, or volume to moles. All right, enjoy. Try some of the activities, and copper tomorrow.